All right, we're going to hit a brand new type of reaction intermediate, and those are radicals. So when we think of electrons, electrons show up in two forms in the molecules that we've seen so far. Almost exclusively, we have lone pairs, and we see electrons as bonding pairs. You know, there's going to be pi bonds or sigma bonds. We have two electrons, pairs of electrons. So when we see a radical, whoops, not a radical, a radical, we have a single unpaired electron. So let's see an example of a structure that has an unpaired electron. So here's a structure. It has 4 carbons and it has an unpaired electron. What does this really look like? Let's draw a condensed representation. We're saying that that carbon has an unpaired electron. Now, radicals themselves are considered an intermediate. Things are called intermediates because they're reactive. So, what are the reactive intermediates? Well, there are anions, there are cations, and we've seen both anions and cations, plenty, especially anions. There are radicals. So now we've hit the third example in these intermediates. And the last one for carbon atoms they're called carbenes. And we will introduce carbenes extremely briefly, but we won't really learn much of their chemistry. So why are these intermediates reactive? Well, in the case of radicals, these do they don't have a full octet. No full octet. So if we look at this carbon in the middle of the screen, it really has 7 valence electrons. And, you know, that's not a full octet. So this carbon is going to do something to try to make sure that it can pick up its 8th valence electron. It's going to try to complete that bond or complete that pair of electrons. So that's where the reactivity in radicals comes from, and that's why we call them reactive intermediates. Now, radicals have their entirely characteristic patterns in terms of how they react and how we show them react. And we touched upon this a little bit when we talked about mass spec and when we encountered radical cations. That's a type of radical intermediate that you encounter in mass spectrometry. But we'll see some of the trends in reactivity in radicals as we work through this particular unit.